All right. Happy Monday. Welcome back. We took a little sort of break. You guys had that quiz, so great work on the quiz. Woohoo. Oh yeah, I read about that Facebook is just out to lunch right now. So Zoom is good. I'm surprised Facebook hasn't acquired Zoom by now, actually. But yeah, that means I'll have well, you guys are too young to be all hooked on Facebook anyways. Instagram though, that's bad. Yeah, everyone's just feeling really unpopular. Oh, I'm not getting any messages. What's going on? I know, I wish email worked like that. Oh, sorry, it's down. I didn't get any emails. Okay, so great work on the quiz. Kind of made you work for it a little bit. I haven't gone through them yet. But what I like to do is usually I just go through everyone's quizzes just to make sure that you're getting marks that you are owed. For example, for this first quiz, right, if you didn't follow the rounding instructions, right, we had to have at least 3 decimal places. That happens. That kind of thing happens.
There were no rounding instructions.
Pardon?
There were no rounding instructions, so I just included as many digits as I was given.
There, that's always safe and good. It's at the top though. So I didn't do it for every single one.
Oh, okay.
Because I don't like to bog it down, but just as in general, it's just, I think it needs 3 or more. Okay. But you're safe if you do as many as you can.
Okay.
Yeah, so that's always safe. Or it should be. Anyways, some tools mark it wrong and that's wrong. So then I have to go through and fix it. But anyways, Moodle's pretty good for that kind of stuff. But I still like to go through and I just make sure that everyone's kind of getting the marks that they deserve. And especially on this first one, right, we kind of make some mistakes. So I will go through and make those adjustments. So if you're feeling like, 3 decimal places, I only did 2. Don't worry for this one. I got you. But of course, that means me going through each one. So it takes a little bit of time. Okay, but do not fear. Yeah, so it happens. Seeing some party time on the chat here. Phew emoji. All right, so what I did was I posted a project. Not a project, I guess it's more of an assignment. It's for chapters 2 and 3. So now that we have tools for summarizing data numerically and visualizing data, I thought, hey, is there a better time than now to make you apply it? No, there is not. Let's see here. And I had kind of a, let's see here, done, save to photos, bring it in. Okay. So here, I was hoping to kind of rip through chapter 4, but there's a lot in there. A lot of it is going to be review, especially if you've taken a stats course like Stat 230. A lot of it is review, and a lot of you are taking Stat 230 with me right now. So if there's something that I kind of rush through, then it's because it's supposed to be review, or it'll be coming up. If you're currently taking Stat 230 with me, then we are going to go through it kind of in more detail, but I didn't want to go through it so fast that you couldn't keep a handle on it, right? And so we'll see how long it takes. So in terms of this week, I'm going to focus on chapter 4, and I posted the chapter 4 summary notes, but like I said, today definitely it's just going to be review if you've taken some sort of stats. And for Stat 230, there's a lot of overlap this week, so that's fun. It's always confusing, but also rewarding when you have overlap in classes. Oh, I know, I heard about this already. Oh, okay, nice. So we'll focus on chapter 4 today. I did realize that, of course, Friday is a Friday, a little blip, Friday afternoon before a long weekend. I'll see what I can do about that. I don't know if you would want me to post a recording so that we can just kind of do it at your own pace, or kind of, so I'd love some, or if you want to have this meeting at this time, doesn't matter to me, but I'll see if I can come up with something so we have some, not free time on Friday, but you choose to spend it however you want. Cover that material when it works. Oh yeah, and then I posted another fun site called Data to Viz. And so what it does, and its sole purpose, is to kind of help you figure out what the most appropriate graph would be, or maybe some graph options. So it does require you to know what type of variable do you have. Do you have a quantitative variable, or do you have a categorical variable, right? Those types of things, that's kind of the main branch. And then it'll kind of take you down a question route. So I'll just show you what it looks like. It really just as a reference. It's not something that I need you to look at or anything, but it's just kind of fun. So here, what kind of data do you have? Pick the main type using the buttons. So if we have categorical data, if you have one oh, sorry, I don't have a pointer. I'm pointing on the screen here, but if you have one categorical variable, there are a series of different things we could do, right? We could do a bar plot. There's a lollipop, kind of fun. That's basically a bar plot with a dot on top, right? You can do a waffle graph. I guess I've never used one or seen one, but that's okay. You can do a word cloud, which we actually talked about, right? My biggest words would be record. Anyways, there's the donut chart, the pie chart, tree map, circular packing. I have no idea what that is. Doesn't matter. Right, and so it just gives you a couple of different options, especially for numerical data or quantitative data, right? And so it just gives you a little bit of a decision tree, okay, that you can use. All right, so, oh yeah, here it is. I posted this chapter 2 and 3 assignment. Okay, so it's going to be due October 11th, so next Monday at midnight. I know that Monday's a holiday, and I could be convinced to bump it to later, but it would be nice if we could keep on a 1-week cycle. So the data set it's using is here. Notice that it's in an Excel file, and so you'll need to be able to bring that into R because I want your report written in Markdown. Okay? And then I want you to submit your report as a single PDF. Okay, and so that's different from what we have been doing, right? We've been submitting HTML. So just that there that I'm asking you to do are 2 new things, right? And so here I'll put need to import this Excel file, and I guess it's a name, so I should capitalize it, this Excel file into R to use it. Okay. And also, we need to install some sort of LaTeX package, right? And so I'm sort of hoping / assuming that you've had to do it in maybe another course. So then it's easy, but if it's not, I am. Pardon?
So that you don't have to teach us.
Exactly. Well, it's not about teaching you. It's just about showing you how to do it. And it depends on what system you're on. But in general, you have to download a LaTeX package. So there's MikTeX, there's TechShop, but if you go, and I'll see if I can find a quick documentation on how to do it. So here I'll say need to install a LaTeX package, or I guess it's called a distribution. Okay, so for example, there's MikTeX, there's TechShop. Which one do I use? I think it's TechShop, and I'm on a Mac, so kind of depends. I think MikTeX might be for Microsoft and TechShop, but there's TinyTech. So something to figure out, right? What do you Google? How to knit to PDF in R. How to knit to PDF in R. Markdown, I should, because otherwise it might give you help for Sweeve, but there. Now I've taught you how to do it. Okay, so a couple of things in there, but once we open the assignment, I was about to click the link. It's not a link here. Okay. There's some instructions at the top. Okay, so you want to submit it as a PDF using a markdown file. Okay, and it's going to be 2 parts. It's going to be one report in 2 parts. Okay, so part 1 is the one that you would submit to the client, which is Heavenly Chocolates in this case. Okay, and then the second part is where you actually go through and you show them, in case they're interested, what you did exactly, right? I'm interested. So, and I'm the client. I get to be Heavenly Chocolates this time. So, right, so the first one is the one that they would probably read and use and make decisions from. And then the second part of the report is, the grunt work, everything that you did to get to those results. Okay. So there's some notes here. There should be no R code and no question numbers in the report for part 1, but definitely both of those. Oh, sorry, it's catching up. Facebook is taking over here. For the second part, I definitely want to see all your R code and just all the question numbers and stuff like that. So it has the information that you're working with here. It's got a summary of the data, but I've also posted that data file, so you could just look there instead. And the question, so the main, and I keep forgetting that I don't have a pointer here, but the question that we're trying to answer ultimately, and that's something to keep kind of front of mind every time you're writing a report, is what are we trying to answer here, right? Does it help us give an answer? So Heavenly Chocolates would like to use the sample data to determine whether online shoppers who spend more time and view more pages also spend more money during their visit to the website. Okay. And then they'd also like to investigate the effect that the day of the week and the type of browser have on sales. So if you're on I don't know, if you're on Safari and you're cruising a website on a Friday, are you more likely to buy chocolates? Yes or no? Right. And so here it's got the questions that you have to answer or address. Okay. What I want you to remember is there's no right or wrong way to report this. Okay. It's going to be, I'm going to read it and I'm going to determine if it's a good report, a decent report, or maybe, no, you guys aren't going to do a bad report. Right? So is it a good report or is it a decent report? Oh, right. And so as long as you address these questions, and they might require you to kind of think outside the box and kind of get creative. There's a lot of creativity involved, right, when you're writing a report, but I don't want you to feel restricted to these questions. You do have to answer these questions, right? But you can go outside of these questions, right? You might not want to. This is only our first one. So if you don't want to, that's okay, right? Stick to the questions, make sure you answer those. But just to remember, right, I can't post solutions because there is no one solution, right? I could post what I would do for my report, right? But everyone's report is going to be a little bit different, right? Okay, so I do want to write that because I think it's really important. And sometimes as students, especially, we get kind of hung up on, oh, did I do that right? Or did I do it wrong? Right? This is one of those uncomfortable cases where there's really, as long as you've addressed the question, there's really no wrong way to do it. There are better ways to do it, more efficient ways to do it, right? But that's what we're here to learn. All right. So remember, there is no wrong way to write a report. Right? Only kind of degrees of good to bad, right? And that's going to come with practice, right? And so there's no wrong way to write a report as long as you address the questions. Of course, if I give you questions to answer, and some of those questions are kind of vague, right? So as long as you feel that you have addressed it, then okay, I'm probably okay with that. So as long as you address the questions as well as the research question. And in this case, I think they had 2 research questions. All right. What was the research question? They want to know if the people who spend more time and view more pages also spend more money. That's research question number 1. And then the second question is if the effect of the day of the week and the type of browser, if there's an effect on the sales. Okay. Good. So I know you guys don't usually start out liking these types of problems, right? Because we want to have, did I do it right or did I do it wrong? Well, there's no wrong. There's no right. Just, we have to get there. Okay. So, oh, that's a lot of stuff to tell you guys. All right. Today we're going to do chapter 4. So chapter 4 is on probability, which of course is a big part of statistics, but also data science, because data science is statistics, right? It's just got it's a different flavor of statistics, but we're still stuck in that same realm. So probability, of course, plays a huge role. If I tell you that if you're considering a couple of stock options and I tell you, oh, the probability that this stock is going to go up is 98%, then you have information that you can make a decision with, right? Should you buy that stock? Should you not buy that stock? Well, it depends on how much it costs, blah, 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 right? But it all comes down to those probabilities, right? And so we need to talk about probabilities. And like I said, this will likely be review for a lot of you, or coming up soon if you're in Stat 230. Either way, here we go. I'm going to grab this whole chunk because there's not a lot that I want to write here. It's because I tapped it just the wrong time. One thing that I find really helpful before we start here is probability is the same as a proportion, right? And we actually already saw proportions when we looked at crosstabs, right? Cross tabulations, we had a table and we had some totals in the margins, and then we were able to kind of find which proportion satisfied some criteria, right? And so we've seen that already, and a proportion is a probability, right? And so for us, I'll say as a note that a proportion is a probability, which is roughly a percentage, right? Usually we report probabilities as percentages by multiplying the probability by 100%, right? And so this is technically a probability times 100, right? But we're pretty good if I say, oh, 0.6 of the population said no, then 60% of the population said no, right? Our brains are pretty good at making that connection. So usually when we report probabilities, we report them as percentages. Okay. So we usually report probabilities as percentages. Okay. But in our calculations, it's going to be really important that we use the decimal, so the proportion or the actual probability. Okay. So while in our calculations, we must use proportions, probabilities. Remember, they're the same thing. Notice that all three P's mean basically the same thing here, right? Proportion is a probability, is a percentage, and so can kind of use them interchangeably. Okay. So for us, right, even if I asked you, okay, what's the probability if you flip a coin, what's the probability of tails, right? You'd probably say 0.5 or 1/2 or 50%. All of those apply, right? All of those are correct. And so what we're going to be talking about is a random experiment. Now, a random experiment is going to yield some random outcome, right? So as soon as you don't know what's going to happen when you do something, so you can toss a coin or flip a coin, you can roll a die, you can make a sales call. You don't know if they're going to make, if they're going to purchase or not buy something at the end of that call, right? So that's considered a random experiment. Stock prices, if we knew it that they were going up or going down, that's not a game, right? And so that we consider a random experiment, okay? And so what happens if you reduce the price of a product, right? Then demand could go up, it could go down, right? They don't want it anymore because now it's not fancy, right? Things could happen and we don't know until we've done it and see the outcome, right? And so what we're going to have is we're going to have a list of possible outcomes, okay? Only one of those possible outcomes is going to actually happen, right? With some probability, right? And that probability hinges on how many possible outcomes there are typically. There are cases that we'll talk about where that's not the case, right? But for now, let's just assume that if we are flipping a coin, there are two possible outcomes, and that's why you said, or probably said, what's the probability of flipping a head? Well, 1 and 2 or 0.5 or 50%, they're all the same. Tail, same thing. We are ignoring, and generally we just ignore the very rare outcome of it landing on its side. It does happen with some extremely small probability, but we ignore that, okay? So if we're rolling a die, right, 6-sided die, 1, 2, 3, 4, 5, 6, we could even take it a step further and we could roll 2 dice, right? And we could look at kind of 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, right? And so on and so forth. So we could have complicated experiments, but for now, nah. So the sample space is the list of all possible outcomes. Now, it is a set. So if it's been a while, or maybe you're unfamiliar with the set notation, right? A set is denoted by curly brackets, set notation, okay. And elements are separated with commas. Okay. Head, tail, HT, right? Depends on how lazy you want to be. The sample space, oh, I guess I should mention, probably know already, but S is the sample space. Typically, oops, especially in kind of these courses that we're taking, S is going to be the sample space. Sometimes it's this like script C, but nah. So our sample space, if we roll a die, would be 1, 2, 3, 4, 5, 6. And so the outcomes, okay, are going to be listed here. Sorry, I've lost my train of thought. The outcomes and the events are a little bit different. So the outcome is singular versus an event is a collection of outcomes. Okay. So there might be cases where I'm interested in just rolling a 2, for example. Sorry, let it catch up here. see if we're here. Okay, so if I'm interested in what's the probability of rolling a 2, right? Well, that would be 1 in 6 because there's 6 possible outcomes. What if I don't care if it's a 2, 4, or a 5? Right? As long as it's one of those outcomes, only one of those is going to happen, right? But I've opened myself up and I say, okay, I'm okay with it being either a 2, a 4, or a 5. Right. And so now I have 3 of the 6 possible outcomes. And so now the probability of a 2, a 4, or a 5, one of those 3 is 1/2, right? Or 0.5 or 50%. I'll stop doing that. No, maybe I won't. I can't stop. Right, they're all the same. All right. Good. So just for some kind of basic probability rules, we don't really need these, but they are the foundation of all the probabilities that we do. And so I am going to kind of go through these kind of quickly because, like I said, we're not going to be testing these explicitly. I might get you to do something on an assignment or something. And maybe I shouldn't have said that. It would make a good multiple choice question. I'll warn you if it is. Okay. The more I think about it, I'm like, no, it's a really good quiz question, I guess. We're talking about it here. So some basic probability stuff. First thing we're going to talk about is the complement of an event. And whenever I say the complement, I always think of that video. Have you guys seen Give Me Compliments? It's by this German guy. Anyways, you should YouTube. And this is just for fun. YouTube, Give Me Compliments. Can't remember who it's by or anything, but anyways, he's like this German guy and he's written this song. Anyways, so when I say the complement, it's all I can think of in my mind. So the complement of an event is just the opposite of that thing happening. So if we talk about the event of rolling a 2, a 4, or a 5, the complement of that would be, let's see if I can do this, a 1, a 3, or a 6, right? Everything that's not 2, 4, or 5. Yeah. So if A is the event of a 2, 4, or a 5, right? And I'll clarify here, the event of rolling a 2, 4, or a 5, then the complement of A we denote by a superscript C, a capital C. I guess it could be lowercase too, but it should be uppercase. Doesn't matter. Big C, little c, they look the same. So the complement of A would be everything in the sample space that is not in A, right? And so we had the sample space, we're rolling a die, and so 1, 2, 3, 4, 5, 6. And so the complement of A is going to be 1, 3, 6, right? All the outcomes in the sample space not in A. So sometimes I'll, instead of saying the complement of A, I'll just read it as not A. Okay. So the I guess I tried to say it there. A superscript C can be read as the complement of A or sometimes I will call it not A. That's just because I'm lazy. Not A. It communicates what the complement is, right? So a lot of the time, what we do is we use a Venn diagram to illustrate these relationships. And so a Venn diagram is going to look like this. Okay. So in general, a Venn diagram is going to be started with a rectangle, and the rectangle denotes the sample space. Okay. So the rectangle is just containing all possible outcomes. Okay. And then what we do is we usually show in the circle, right? This circle is some event A. Okay. Then the complement of A is everything inside the sample space, not in A, right? So not A. Okay. In terms of probabilities, right? What's going to happen? Did I show you guys the half do or half don't? Did I do that? Half do or half don't? Okay. It shows up choppy when I show it on my iPad, but it's a clip from Superstore. If you guys watch Superstore, it's really funny. So I think I showed it in my Stat 230 class, but not, I can't remember. It was a while ago in that case. But anyways, I'll post it because it's really funny. But basically knowing a yes outcome is the same as knowing the probability of a no outcome, right? If it's two possible outcomes, right? A happened or it didn't happen. Okay. And so I'll post that video because it's pretty funny. So anyways, the probabilities, usually we would rewrite this as the probability of the complement of A is 1 minus the probability of A, right? And so here, this is kind of a silly example because the probability of A, if there are 6 possible outcomes, is 3 and 6, right? There are 3 outcomes equally likely out of 6 possible outcomes. But then the complement is just 3 over 6. But why is that, right? It's because 1 minus 3 over 6 is 3 over 6. That's not very useful. So if the probability of A is 0.30, right, then the probability of the complement of A, so if the probability of A happening is 30%, what's the probability of A not happening, regardless of what we're talking about, right? So 0.7, awesome, is 1 minus 0.30, which is 0.70. Notice that our brains already do that. It's already built in somehow. By some, I don't know how, but our brains already do that. And I think that's pretty cool, right? Because we know that all the possible outcomes have to add to 1 or 100%, right? And that's what it hinges on. Okay, good. So the addition law talks about what if we have 2 possible events that we're interested in. And I'm going to grab this whole chunk here. So if we have two events, A and B, usually we use these kind of placeholder notations. Then what if we want to know if A or B or both happen, right? And so if we start and we look at this Venn diagram, then we start again with the sample space in the rectangle, and then we have a circle for A and a circle for B, right? And maybe I'll use a different color here. So A is this event, and hey, that's a bad color. Needs to show up on here, right? And so A takes up some space, B takes up some space, but what if it's possible for A and B to happen at the same time, right? That's a thing. Okay, and so here, this little section is where A and B, should probably grab a darker color here. A and B happen at the same time. Okay. So we make room for that possibility of both of them happening at the same time. Okay, so here, if we want to know the probability that A or B or both occur, and I want to highlight that it is for both potentially, if they can happen at the same time. There are instances where they cannot happen at the same time, and that's fine, but this or both throws people off often. So that's why I want to highlight that. So we're going to talk about the union of the events and the intersection of events. Now, the union of events is exactly as it sounds. It's both of them together, right? A or B is the union of A or B. And what we do is we use notation for that. So the union of A and B is denoted by A capital U B. It's not really a U, but it definitely looks like a U, right? And so that's the union, and that's what we're going to read as A or B. Okay. So the union is A or B, and I should follow it up with or both. But from here on out, that's understood, right? So A or B or both, okay? But the union makes room for any of those. So if we go back to our Venn diagram here, A is going to have, A is going to have some set of outcomes in the sample space, right? And B is going to have some set of outcomes in the sample space. So if we want to know if A or B happen, right, there could be some overlap, and we don't want to count that twice, right? And so we can visualize it with a Venn diagram. What's confusing but also useful, especially in the beginning, it's confusing, but then it becomes useful, is that these circles can represent the events A or B, or they could represent the probability of A and the probability of B. It actually doesn't change anything. Okay, so in a Venn diagram, oops, the circles can represent either the events A and B, oops, I'll clean that up. The events A or B, or the probabilities, the probability of A or the probability of B. Okay. Just for kind of a very simplified example, right? Just so we can kind of see how it would work. If you roll a die, then we know the sample space is 1, 2, 3, 4, 5, 6. And then what if I tell you that, okay, so let A be the set of outcomes, so the event, right? Because an event is a set of outcomes. So A is going to be rolling 1, 2, or a 6. I don't know why it took me so long to make up numbers. I only have 6 to choose from, but I did it. And B is going to be the outcome of either a 5 or a 6. Okay. We can find the probability of A, right? The probability of A is 3 and 6, right? Or 50% or 0.5, doesn't matter. And the probability of B, there are only 2 outcomes in B, right? So 2 out of 6. Yeah. In this case, there's overlap, right? Notice the overlap here. There's overlap where 6 happens. So what we could do is we could visualize the events, right? So visualize the events. We've got our sample space, and maybe I'll scoot this over so I can do them side by side, or visualize the probabilities. Kind of screwed that up, but that's okay. I think you're with me. What we're going to see is that they look the same. Okay, and so if we have A, so in the set A, I have 1, 2, and 6. 1, 2, and 6. They're just kind of floating around in there, right? There aren't a lot of options in this case because it's a very simplified situation. And then I have B, which also has a 6 in it. So notice how I scooped it up with the overlap. And the other one that's floating around in B, but not in A, right, is 5. Okay. And then what's missing? Well, I have 1, 2. I don't have 3. So that's in the sample space, but not in either of these. 1, 2, 3. I don't have 4, but then I have 5 and 6. Okay. So we can visualize all those outcomes, but really what's going to happen is we're going to want to talk more about these probabilities. So if I have A and B, then I can talk about, and I think it might, yeah, I don't want to do irrational numbers. So I'm going to do 1 and 6 here. And then here's where I need to make a choice, right? The total probability of A is 3 and 6. Oops. If I was only concerned with the events in A and only A, so not B, I would have to take out that overlap, right? We're not going to bother with that because the total circle is 3 and 6, which includes that 1 and 6. And then here, this total circle is 2 and 6, right? Which includes that overlap of 1 and 6. Notice how these two are the same. They're showing the same thing, but eventually we're going to start just caring about the probabilities. Yeah. So maybe I'll write that. That always helps. Notice that these diagrams show the same information. Okay. So the union of A or B, or A and B, I guess, the union is one of those two or both happening. So then we're going to talk about the intersection. The intersection of two events is exactly as it sounds. It's where they intersect, right? It's where they both happen at the same time. And so we saw that here, right? This overlap, so A and B happen at the same time, that's going to be the intersection of A and B. Okay? So how we denote that is the intersection is denoted by this A and an upside down U. Okay, how I remember it is so U is or, and an upside down U is and how I think of it is I just kind of make an A out of it, and then that triggers me to say and then the other one is or, right? We only have two options. Okay. And so so that's my one trick, I guess I could give you. Otherwise, it's just a matter of memorizing. Okay. And so it's going to be the outcomes that are in both A and B. Okay. So what we're going to look at is what if we want to find the probability of A or B, right? If we have just the A circle, the probability of A taking up some space, right? And then we allow for overlap with B, so now the B circle takes up some space, then the probability of being in one of these regions is going to be the probability of A plus the probability of B. So adding up the probabilities of each circle, and then we have to subtract the overlap. How, in my mind, it's basically like smoothing it out. So it's just one layer, right? Because you've counted that overlap twice. Remove the overlap. So it is not counted twice. Right? It'll be counted once, but not twice. So we saw that here. If I have just the probability of A, so the whole circle of A is 3 and 6, and then I have the probability of B, which is 2 and 6, but then I've counted that 1 and 6 2 times over, right? So then I have to subtract it one time to just make an even surface. Okay. So that's the addition law, or I don't know why I went there. Here, already worked there. So let's do this little example here, just so you can see. But I also had notation I want you to use here. Copy. So the questions that we could ask look something like this. So if we have a study that's conducted by human resources, then the study might show that 30% of the employees who left the firm within 2 years did so primarily because they were dissatisfied with their salary, 20% left because they were dissatisfied with their work assignments, and 12% of the former employees did not understand the question and said both. Why didn't they understand the question? Because it says primarily. You have to pick one, but they didn't understand. So they said, actually, it's both. Fine, okay. It's also just to make room for us to be able to answer this question. But I do take issue with the primarily. So anyways, so what we're given, right, is we have the probability of them leaving because they were dissatisfied with their salary. And down here, we're going to let S be the event that the employee leaves because of salary. You don't want to write that out a ton of times, right? So we're going to develop some shorthand here. And then we're going to develop W as well, which is the event that the employee leaves because of work assignment. So things that were given here, we're told that the probability of S, so they left that because the salary is 30%, but probabilities have to be in decimals, right? So that's going to be 0.30, right? But like I said, our brains are really good at working back and forth like that, okay? And so as long as you remember that you need the decimal for math, for calculations, then you're safe, okay? And so 20% left because they were satisfied with their work assignments. And so the P of W, isn't that prisoner of war? POW. P of W in this case is 0.20. Okay. And then we're told that the probability of S and W, which I should use probability of S and W, right? Here I want to highlight that that's all it's saying, right? S and W, but here I'm using that intersection notation. Was 0.12. Okay. What's the probability that an employee who leaves within 2 years does so because of dissatisfaction with salary, dissatisfaction with the work assignment, or both, right? And so here, what we want to find the probability of S or W. And maybe I'll do the same thing that I did underneath. Okay. So what we could do, and if you want to, you can definitely use the Venn diagram, right? Or we can use the formula, but we're going to arrive at the same answer. And so I'll show you both, but as long as you're able to develop an answer, I'm happy, right? You don't have to use the formula, you don't have to use the Venn diagram, but you have to use one of them. How do we show that in a Venn diagram? Anyways, can't think of it right now. So you have to be able to use one or both. All right, so we can solve this using a Venn diagram or the formula or both. You'll get the same answer though, kind of redundant. We'll start with the Venn diagram. So now my sample space is just all the possible reasons that someone would leave right? And so we don't need to worry about what all those reasons are, but we are going to block it off and say, okay, all the possible outcomes are in here, okay? And then I have a circle for S. And maybe I should make this, can I make this bigger? Haha. I can. Okay, now I got to keep up with my drawing here, okay? Hey. Need a thicker pen. Haha. Okay. What's key when we're drawing a Venn diagram is we need to start in the middle, right? So a Venn diagram with two outcomes looks like this. And maybe I'll scoot this over here. And here, a Venn diagram, oh, that's why it looks so weird, because my pen is so thick. A Venn with three outcomes, or three events, I guess, by default is going to look like what? Like this. There are, of course, default Venn diagrams for 4 outcomes, 5 outcomes, but they get really, really nasty, okay, really quickly. So usually we only end up using them for 2 or 3 outcomes. So what's important is that you start with the area that has the most overlap, right? Because then you want to subtract that overlapping area from the remaining areas, because the total area has to be 1, okay? So we always start with the area with the most overlap. Okay. So in this case, right, that would be the area of S and W. And we were told that this area here, the probability of S and W was 0.12. Okay, which means that the remaining area, this kind of half moon area, I call them half moon areas because then it really highlights that we've carved out the overlap, right? And so here, if I think about this area, I'm not going to write it in probability notation. Why am I avoiding that? Because this is the probability of W and not S, right? Okay, fine. We have it. We know it. Right? So it has to be in W, but it can't be in S because that's the overlap. And so this is going to be 0.2 minus 0.12. .08, I think. Sold. Okay. What about this area here? This is the probability of S and not W. The whole circle of S was 0.3. Sorry, it's catching up here. 0.3. But then I have to subtract the overlap. Now I'm doubting myself. I'm good. 20 minus 12. It's 8. I'm ready to lock it in. 10 more, 18. Okay, I got this. What's the probability of it being something else? So not the salary or the work assignments. Well, I can take each of these areas, right, and subtract them from 1, because the total area here has to be 1. So the total area here total area must be 1, right? Otherwise, you haven't listed the entire sample space. So then what I can do is I can find the probability of not S or not W, or what I'll say here, the probability of, it gets a little tricky because there's formulas that you would use here, but the probability of S or W, the complement of that is 1 minus 0.18 minus 0.12 minus 0.08, which is 1 minus, 0.18 minus 0.12 minus 0.08, 0.62. So now you have all those probabilities that you might be interested in. Ready for the formula version? Formula version is going to be a little bit easier, I think, right? Drawing out this Venn diagram takes some work, right? But if we want to use the formula, right? Remember, formula is this one. Oh, there was a question we were supposed to answer. What's the probability that an employee who leaves within 2 years does so because of S or W? So we want to find S or W. So the probability in this case, S or W, is, well, it can be in this lonely half moon S circle, or it can be in both, right, in the overlap, or it can be in the half moon W circle, right? And so I guess if it's a half moon, it's not a circle anymore, but you get the idea. 0.12 plus 0.08. And I think I just had it, but let me just do it again. 0.18 plus 0.12 plus 0.08, 0.38. Or we can solve this using the addition law. Key is that I want to map my generic A to one of those events and my generic B to another one of those events. And then you want to be really consistent with how you map them, right? So if I'm going to let A be S and B be W, then I want to be consistent here. The probability of S or W is the probability of S plus the probability of W minus the probability of S and W. We have all those probabilities, right? And so we can say, okay, the probability of S in general, right, is 0.3. Let me just, I shouldn't have scrolled up, but I had to confirm the numbers, 0.3, 0.2, and 0.12. So catch up here. So 0.3 plus 0.2 minus 0.12. A little bit different than how we got there before, but it's going to end up being the same value, right? I will confirm 0.3 plus 0.2 minus 0.12 is 0.38, which is the same as what we found earlier, right? I feel like the formula is the quicker and easier way to do it, but you can pick your way through the Venn diagram and you can get to the same answer if you don't like the formula, right? And so either way, the answer is 0.38. Yeah. There are times when, especially in kind of just plain language, we talk about mutually exclusive events. Okay, so, oh no, those two things are mutually exclusive. What does that mean? It means they can't happen at the same time, right? And so in terms of probabilities, what does that mean? Let me grab this here. So mutually exclusive events means that they cannot happen at the same time. Okay, so two events are said to be mutually exclusive if the two events have no outcomes in common. Okay, so what does that mean in terms of probabilities? It means that the probability of A and B is 0. Right? That's useful because then we can alter our formula from before, right? The addition law. If A and B can never happen at the same time, right? We have that little Venn diagram in the notes, so I'll bring it in here. But then they would just be two circles with no overlap, right? It's a special case where they're mutually exclusive. Bring it in here. Sure, sneak it in there. So we have A can happen, B can happen, A or B can happen, but they can never happen at the same time, right? It's just a special case. And so in terms of the probabilities, right, what we see is the probability of A and B is going to be 0. So we can leverage that in our addition law and say that the probability of A or B happening is going to be just the probability of A plus the probability of B minus 0, right? Because the probability of these two things happening at the same time is 0 because they can never happen at the same time. Okay. This is a special case. So if you have to kind of purge one of the cases from your mind, let it be this one. Okay, this is a very special case. If you want to, we could always just start with this. It's called the general addition rule or the general additive law, or I guess addition law in this case. It's got kind of many names for the same thing, right? But in general, we can always use this addition law because it'll always apply, right? And so here, we can always use the addition law as long as we remember the special case where A and B are mutually exclusive, where A and B are mutually exclusive. means that the probability of A and B is 0. So if you just always start with the probability of A or B is the probability of A plus the probability of B minus the probability of A or B, right? Then, or sorry, A and B. Let me fix that. Too fast, too furious. Equals 0 if A and B are mutually exclusive, or we can call them disjoint. So here I'll write mutually exclusive, but I'll add that to our very long list of multiple names for the same things. So mutually exclusive, I'll say here. Where can I write this? Also called disjoint, right? Disjoint means they have no outcomes in common. So sometimes I'll let that slip, and that's why I wanted to warn you. Okay, good. Do I want to start a fresh section with 2 minutes to go? No, not really. So have a read through the section, right? And then it might be refresher, might be new, okay? But conditional probabilities are, if we know that one outcome has happened already, then does the probability of the second outcome, is that affected by the outcome B already having happened? Okay, and so that's conditional probability. And then we are going to talk about Bayes' theorem, but I kind of want you to not worry about it too much, because you have probably worked with tree diagrams, or you will work with tree diagrams, and I'll show you how they're the same. And also Bayes' theorem is just a fancy case of conditional probability. So we'll pick that apart on Wednesday. If you have any questions, let me know. Otherwise, I'll see you on Wednesday. And I'll stop this recording here.
Well.
See ya.